this video we are looking at interval and set builder notation. So I wanted to show some intervals here. Here's 5 to 10, and going some old school notation, not the parentheses and circles, or parentheses and brackets, doing the open and filled in circles. Open meaning it doesn't include the value, filled in means it does. So this is 5 is less than h less than or equal to 10. And in set builder notation, that's a formal way of writing what values are represented. We'd write h such that this vertical line here means such that 5 is less than h less than or equal to 10. And in interval notation, we just do parenthesis 5 comma 10 bracket. So going back to our parentheses and brackets. In the second case, the 5 has the dot, 10 has a circle, so 5 is less than or equal to h less than 10, strictly less than 10. So h is less than 5 less than or equal to h less than 10. And so notice there's a bracket here, and there should be a parenthesis here. It doesn't quite look like that on my screen, so I'll exaggerate one. And then we have two open circles, so it's not going to include either of those values. So 5 less than h less than 10. So h such that 5 less than, should be 5 less than h less than 10. That's messed up. And we have the parenthesis and parenthesis with the 5 and the 10. Here we have 10 open circle, and it goes down with no limit. I mean, the arrow means it keeps going that way. So this is just h is less than 10. So it's like a brace thing like that. H is such that h is less than 10, and we do negative infinity to 10. And then we have this next one where we're at open circle for 10 goes up forever. So h is greater than 10. Since it's open, see errors in this document that I borrowed. That's strictly greater than. Maybe I should do this. Maybe I'll make this correct by filling this dot in right here. There we go. Okay, now it's correct. H is greater than or equal to 10. H such that h is greater than or equal to 10 and goes 10 to infinity. And it does have the bracket by the 10 and the parenthesis by the infinity. And this next one, even though we have the 5 and the 10, it goes past it in both directions. So that's all real numbers, and we write that in set builder. Well, actually, you could say h such that h is an element of the reals. That's how I would have done it. That's not how your book did it. And then negative infinity to infinity for the intervals. So to combine two intervals using the inequality notation, using the word or, combine the intervals with the symbol U for union. For example, there we go. If x is greater than 3 or less than negative 2, we have negative infinity up to, that should be a 2, union 3 to infinity. So that's what that is showing on a number line. So let's just say this is negative 2, negative 1, 0, 1, 2, 3. That means we'd have an open circle here shading down. We'd have an open circle here shading up. Okay. So how to describe the set of values using interval notation given a line. Identify the intervals to be included in the set by determining where the heavy line overlays the real line. At the left of each interval, use the squared off bracket with each end value that to be included in the set with a solid dot, or for each excluded end value an open dot. Should be another parenthesis there. I think we should have done this there. Real-time editing. Okay, boom. Okay, whatever. At the end, so those of you who actually watch the videos, you can say, hey, I saw your correction. Oh wait, maybe I meant this. That for each excluded. That's what I meant. That was supposed to be a space there. Okay. Now I got it correct. A parenthesis for each excluded end value, open dot. That's what I meant. So it's all about a space right over here. Okay. At the right end of each interval, use that bracket for each end value to be included, or the parenthesis. There we go. For each excluded end value, open dot. Use the union symbol to combine all intervals into one set. So, given the figure, specify the graph set in words, set builder notation, and interval notation. So, in words, I'd say this is the numbers or values that are less than or equal to -2. So, the values less than or equal to -2, or values that are greater than or equal to -1, and strictly less than, I'm going to say the 3 because it doesn't include the 3. So for set builder notation, I would say x such that x is less than or equal to -2, or -1 is less than or equal to x less than 3. So it's a strictly less than on the 3. And then in terms of interval notation, so that was B, this is A, we say C, -infinity up to -2 with a brace like that, or bracket like that, union -1 to 3, but with a parenthesis. Okay, there you go. Okay, so determine the domain and range for the graph. Write your answer in interval notation and set builder notation. So look at our x values. We have the 3 and goes up to the 1, but not inclusive. So domain would be, boy, I'm not doing very good writing, x such that -3 is less than or equal to x less than 1. Or we could write it as a bracket -3, comma 1 with a parenthesis. Our range would be, it goes from -5, and it goes past this 3, it goes actually all the way up to this 4. So we look at the vertical part, and it's inclusive of the 4. So that's going to be, I'll say y such that -5 is less than or equal to y less than or equal to 4. And I would do bracket -5, comma 4. Now, technically, you could have just used the same variable, but it confuses people to do that. Okay, let's go on to this next one. Given the figure, identify, get to the next page, identify the domain and range using interval notation. Okay, so our domain, we're going from 1950s to 2000. So our domain is going to be 1950 to 2000. And the range, looks like we're down here at, I kind of want to say 48 in millions, and it goes up to 90.